Today we're going to be exploring the massive updates coming to the Linux kernel version 6.17. Many amazing updates, including the storage, networking, and overall system calls and improvements are being made, and this is shaping up to be quite the merge window. So let's get right into it, as the first round of updates we're going through has to do with storage updates. These storage updates, submitted by Christian here to Linus, are part of the virtual file system file attribute for Linux kernel 6.17, which are going to work on things like replacing some system calls. As you can see here, file get attribute and file set attribute, file system IOC fget x attribute, and fs IOC fs set x attribute. These new system calls are going to provide a cleaner, more extensible way to manage file inode attributions from user space and fix a long-standing limitation where special files, things like FIFO sockets and block devices, could not inherit or change attributes like project quotas used in XFS. So this is going to actually improve project quotas in XFS, which could be attached to a directory. All new inodes in these directories inherit project ID now set on parent directory. With these new system calls, programs running user space outside of the kernel can now manage metadata about files stored in these inodes, which is a more modern and flexible approach. This all matters as it's a way to modernize the virtual file system, which is an abstraction layer in the Linux kernel that provides an interface which accesses all types of file systems, including ext4, ButterFS, XFS, FAT, so on and so forth, no matter how they're implemented underneath the hood. This matters because the old way of setting these inode attributes was inflexible, confusing, and not able to be used by all file types. Great additions in order to standardize and simplify the virtual file system to be used on the kernel. Moving on to the next merged patch, we have Eric here submitting new code to Linus Torvalds, which would update the kernel's cyclic redundancy check code. It's going to do a few things, including code reorganization, which is going to be used for checksums and error detection. It's now being consolidated under the libcrc instead of scattered across Arch or architecture libraries. This means a cleaner code base and improved performance by inlining code and reducing unused code. This also is going to create a performance boost, specifically on x86 64 CPUs that support a very specific flag, which is this VPC LMU LQ DQ code. Again, a improved performance on these newer CPUs. This flag specifically here is an instruction set that handles vectorized polynomial multiplication, and this will improve things significantly for large data blocks that use the flag. We also get a simplified crypto API with this patch, which will make the crypto subsystem leaner and more consistent here when using crypto stash wrappers. We've also done some cleanup, including removing unused hardware from the CRC drivers. And for those of you who don't necessarily understand what CRC is, CRC stands for Cyclic Redundancy Check. It's a mathematical algorithm used to detect errors in data transmission and storage. So you can imagine this is pretty cool because we're going to get faster checksumming out of this, which includes better performance for file systems like ButterFS, networking, and crypto operations. It's very cool to see all of this being proposed to be merged into the Linux 6.17 kernel release. Here are the performance results. So for those of you who can't quite get your head around what kind of a change this makes, well, we do have some performance results right here. These are results shown as a benchmark comparison of CRC performance before and after enabling the new implementation or patch, a highly optimized version using the AVX-512 plus that flag that we're talking about for the VPC, vector polynomial multiplication on x86 CPUs. The function tested CRC computation speed in megabytes per second, and you can simply see the before and the after with quite a significant speed up on modern CPUs with large data chunks. As we can see here, we're using 4096 byte data chunks with over a 3.2 times improvement on some of these units, like right here. We went from, let's just call it 25 megabytes per second to over 78 megabytes per second. That's an incredible performance boost. Now, the performance results are a little lesser the smaller the chunks get, but are still significant. For example, on the Intel Emerald Rapids, we went from 19 to 29 megabytes per second. Anyways, with that all being said, the ZMM registers are warm, so they don't quite tell the whole story. While significantly improved older Intel CPUs, Intel still does have around 2000 nanoseconds of ZMM warm-up time, where instructions execute about 4 times more slowly than they do when normally operating. With that caveat, significant improvements, as we'll have better data integrity checks with lower CPU costs and better performance on workloads. Fantastic. Let's move on to the next improvement here for 6.17. As this time we get a significant networking improvement, all with a simple patch. This patch for Linux kernel 6.17 swaps the synchronized RCU with the faster synchronized RCU expedited in the lock dependency under register key function. What does that mean? Well, first off, the sync RCU function is the standard read copy update synchronization method used to safely wait until all readers are done before freeing or changing data. Now, this is slow because it has to wait for the CPU to go through its scheduling phase or state, but a faster alternative now is being used, forcing CPUs to respond quickly by using interprocessor interrupts, which is much faster and less disruptive. And we get that with sync underscore RCU expedited, EXP. I'm shortening these up, of course, so I don't have to write a bunch, but you get the idea here. So why the change? Well, this one line change makes a slow kernel safety check run 10 times faster during network updates by using faster synchronization methods, which will improve the responsiveness. Should reduce user visible network freezes during config updates or changes in important cloud and data server debugging workflows. And we can think of this as indirectly speeding things up, as it doesn't necessarily speed up in actual data transmission, but it does reduce the downtime when changing network configuration, meaning live network configurations are a lot faster, downtime for service or the traffic during updates is reduced, and better performance for automation tools and containerized platforms. It won't make the packets move faster, but it will definitely make the networking infrastructure more responsive and less disruptive when using Linux, which is critical in modern environments. A great networking patch, all made by switching out a simple function for Linux kernel 6.17. And we do get a little bit of an example here. For example, a simple TC command to replace a Q disk could take 13 seconds time. Right here, to replace Ethernet 0 root handle OX1 MQ real took 13.195, user 0.001, system 2.7. After the improved expedited function used, now we get real 1.7, user 0, system 1.6. A 10x improvement on network connectivity changes. Fascinating. Let's move on to the next one. But before we do, take a moment and subscribe below. You wouldn't want to miss learning about the Linux kernel in future videos. YouTube can get finicky, and also smash that like button on the way back up so other people hear about these updates, as we got a cool new update and patch on Linux 6.17 to improve handling of lost disks in multi-device systems. This is big, as it's always important before losing one device in a RAID setup. For example, unplugging a disk from a ButterFS array would potentially trigger a full file system shutdown, even if data was still recoverable from redundancy, meaning there could be potential data loss. Well, now file systems can gracefully handle single disk loss, reducing downtime and preserving system availability. So this is only for multi-device file systems, but a new hook was added in that allows file systems to intercept device removal events and decide if they should continue running code, which is pretty cool. As this new super operations remove bdev callback will try to remove bdev callback first inside of its file system bdev mark dead. If the callback returns 0, meaning the file system can handle the device loss, then exit without doing anything else. If there is no such callback, the callback return non-zero value, continue to shut down the file system as usual. This means that the new remove bdev should only do the check on whether the operation continue, and if so, the file system specific handlings, the shutdown handling, should still be handled by the existing shutdown callback. And the first file system to implement these is going to be ButterFS, which will add both callbacks soon. Basically, this is a major win for reliability and fault tolerance in Linux file systems, especially for RAID-capable file systems like ButterFS or BCacheFS. So at this point, you might be asking yourself, well, when am I going to get all these updates for the 6.17 kernel release? Well, we should hopefully be seeing some sort of a release candidate 1 release during August, with a feature freeze and testing happening in September, and hopefully a October 12th, 2025 expected final release. It's going to take time for a lot of distributions to actually put in the Linux 6.17 kernel, unless you upgrade on your own for your system. But nonetheless, a lot of exciting changes, including this very interesting fix here of a 30-year-old limitation to ELF, as this simple fix here addresses an issue of an outdated and unexplained kernel check that limited the number of program headers in ELF binaries, and it dates back to 1993 or Linux kernel version 0.99. What's the issue here? Well, a script-generated ELF binary with 78 program headers failed to run on an ARM64 with the 4K page size, showing an error while it ended up working fine on systems using 64K page sizing, and that simply allowed for more headers due to a relaxed alignment rule. And notice this alignment right here, size has to be greater than the ELF minimum alignment. The kernel had an arbitrary restriction here, which was ELF min align divided by page size, which rejected binaries with too many headers, even though ELF spec does not impose these limits. Quite wild as we fix a long-standing compatibility issue that's only surfaced on edge cases. Again, this was in the kernel since 1993, over 30 years at this point, and really since the beginning. And we're seeing this introduced and merged into the 6.17 kernel as well. And if you want to level up your Linux experience today, check out my checklist, cheat sheet, mind map, and new flashcards, all at SavvyNik.com. And there's even more to cover, this time with Silicon on Linux, specifically Apple M1 and M2 Macs. With this kernel release, we'll introduce support for rebooting Apple Silicon M1 and M2 Macs via the new Apple SMC System Management Controller driver, something that was only previously available on Asahi Linux. This new System Management Controller is being merged into the mainline kernel. So those of you who are using Apple Silicon with Linux and outside of Asahi Linux, you can now properly shut down and reboot your systems without relying on downstream patches. This brings full upstream support for rebooting the Apple Silicon, a basic system function that was missing until now in the Linux kernel, and is going to give better support for people using Apple laptops, which is a significant step aligning core functionality with user expectations, of course. And we see these DT bindings for power on reboot. On Apple Silicon machines, a clean shutdown or reboot requires talking to SMC and writing to NV mem cells. Add a binding for this MFD subsystem so we can see, since we got the driver, we can now use the driver to actually communicate and properly do a clean shutdown or reboot process. Fantastic. So many weird and quirky things that you wouldn't think of that are required by hardware and systems, which you wouldn't quite expect. Like, it's pretty wild that you have to write through the SMC and these NVMem cells just to be able to reboot or shut down things on a Silicon Mac. Either way, we're making strides across the board, whether it's an Intel, AMD, Silicon system, the kernel has your back. And now another patch that is adding efficient zeroing support for SSDs. This patch here from Christian, sent out to Linus, introduces a new phallic FL write zeros flag to the phallicate system call, allowing file systems like ext4 to efficiently zero out data that's out of data ranges on modern SSDs and SCSI drives without physically actually writing those zeros. So modern SSDs like NVMe's and SCSIs support fast zeroing via unmap or deallocate commands. This update will add kernel plumbing and flags for these specific types of SSDs. It will also extend phallicate with a new flag, which we already mentioned here. And it's important because it reduces write amplification and I/O overhead when clearing or initializing files. This means faster and more SSD-friendly zero-style writing instead of having to use the old dev0 method, which is a file that has zeros that would then write to the storage disk, and it will help promote file system performance, especially when you have sync write heavy applications, aka database or journaling. This new patch is going to let the operating system quickly zero out parts of a file on SSDs without actually writing all the zeros out. The old way used to write zeros, again, using DD and the dev0 device. The new way, if an SSD supports it, the kernel can now mark the space as zeroed instantly, leading to way better performance in applications that need to proper wipe storage. Very cool stuff. As we have even more improvements, this time with EROFS. EROFS stands for the Enhanced Read-Only File System. It's a Linux file system designed for high-performance compressed read-only use cases, especially on mobile, embedded, and container systems. Where it's used, things like Android, containers where we have immutable root file systems, and embedded systems again, where we have firmware images that are only used in the read-only state. It gives Linux a fast, efficient, and modern read-only file system, enabling smaller images and faster cold starts. So this patch here will improve support for metadata compression. This makes the read-only file systems even smaller, but slightly slower, although saving more space. Directory reads now also have become 2.5 times faster thanks to the new read-ahead support when listing large directories, aka ones with over 12,000 files. This means we're going to see a save in storage space and improved read performance when using EROFS, making it more practical for real-world systems that rely on very fast, compressed read-only images. Very cool to see yet another performance increase with some simple patching. That's what's so cool about the Linux kernel. Anyone can contribute to it, anyone can make improvements, and we see them non-stop. And it's not all just performance boost, as we get quite a major update to the networking stack. This particular one, with thousands and thousands of lines, expands support finally to the Wi-Fi 7 or the Broadcom 800G Ethernet stack, the Intel virtual machine networking, and Realtek USB Wi-Fi devices with new power-efficient features. So the breakdown here is that Wi-Fi 7 EHT support continues, especially on Qualcomm ATH12K, Intel, and MediaTek drivers, but new Realtek USB Wi-Fi support for things like the RTL 8851 and 52BU are being introduced. Improvements to multi-link operation, beacon handling, and regulatory support for 6 GHz. As we get notable progress in the Wi-Fi 7 space, we're seeing general improvements, including multi-link operation, continued additions for that EHT or extremely high throughput support, and support for new SDIO-based Broadcom Wi-Fi devices, which are really the early Wi-Fi 7 integration path. It's pretty cool, as it doesn't necessarily complete the Wi-Fi 7 support, but it also is building out on a lot of features that are going to make for Wi-Fi 7 support. It's a massive patch, and this is planned again to be merged into Linux Kernel 6.17. And now finally on to a controversial patch submission. As Kent Overstreet keeps working on BCacheFS, we had a falling out between Linus and Kent, the lead maintainer of BCacheFS, which left Linus finally saying, "I have pulled this, but also per that discussion, I think we'll be parting ways in the 6.17 merge window. You've made it very clear that I can't even question any bug fixes and I should just pull anything and everything. Honestly, at that point, I really don't feel comfortable being involved at all." And the only thing we both seemed to really fundamentally agree on in the discussion was, "We're done." Signed off, Linus, and that left a lot of people thinking what exactly is going to happen to BCacheFS, as this was very ominous, "We're done," and we haven't heard anything from Linus on the clarification on what this actually means. Are we going to be removing BCacheFS completely from the Linux kernel? Are we going to pull it back out of experimental in the Linux kernel? What's happening? And we still haven't got an answer, but Kent is pushing forwards, as he's actually making some BCacheFS changes for the Linux kernel 6.17, and also making a bold prediction. Schedule notes for users. I've been digging through the bug tracker and pulling users to see what bugs are still outstanding, and it's not much. So the experimental label is coming off in 6.18. As always, if you hit a bug, please report it. This was actually sent to Linus, so we're going to be hopefully seeing a response soon. We have not quite yet seen that response, but this might actually force Linus to make a response. And you wouldn't want to miss that, so make sure to subscribe below and smash that like button on your way back up. We're about done. I do want to cover these BCacheFS changes for the 6.17 since that's the theme of the video, and these are all really just bug fixes and cleanup, including a major performance bug that's been fixed for file deletion, which cache deleted keys were causing slowdowns. There's a better read diagnostics tool for sub counters, a less aggressive congestion tracking, and improved cache promotion logic. Meta writes are no longer throttled. No cal writes can be rebalanced now, and recovery now reconstructs more missing inodes. These are all great backend improvements for stability on this file system, but again, the big question in the background and in everyone's heads is BCacheFS going to be removed from the Linux kernel? Again, don't miss Linus's response, as I will be tracking this very carefully and seeing what replies come out of this. Maybe we'll get some clarification soon. Let me know what you think about Linux Kernel 6.17. Did I miss something that you're excited about? Post it in the comments section below. Catch me in a great community on Discord, and I'll catch you in another video. Thanks for watching.